Okay, so now that we have done the first two ways of solving any systems of equations, meaning we did the graphing and we had done it by substitution, we're going to finally look at the last way of solving systems, which is by using elimination. All right, so let's see. Okay, there. So now let's see. So again, like the intro, today we're going to talk about solving systems via elimination, and it's going to take about a few days at least, because there are three types of ways you can eliminate. You can eliminate variables when you solve systems. Okay? And that's what that means actually. Elimination means eliminating a variable. All right, so it's kind of like combining like terms. So let's jump right into it and take a look. Now, again, as you can see, uh, with elimination, I just want to say this, that most of the time, almost all the time, you'll see equations in the standard form. Whereas with graphing, right? Remember the first thing, the graphing one, the very first time we did this, right? Graphing is typically given in the slope-intercept form because that makes it easy to put it in the graphing calculator. And also with substitution. So for example, if you want to graph this, you can put it in the graphing calculator, right? So that's the first way. The second way of doing that would have been to substitute. And then you can solve it, right? And so today, the third way, we're going to try to learn how to use the elimination method of using this. And it's typically, the questions typically are given in the standard form. So let's take a look and see what this is all about. All right, now, of course, doing this for the first time, using elimination, I'm going to keep it very, very simple. So I'm going to get rid of all the ink here. All right, let's just focus on what we need to focus on. Now, here, the way elimination works is that you want to identify a variable, either the x up top on the first equation, or the x in the second equation, or the y in the first equation, or the y in the second equation, and find out, hey, let's see if there's a, I don't want to use the word, let's say if there's a weak spot that we could sort of attack the question. And the way you identify that spot is to see, okay, which first choice is this? The first choice is, okay, let's see if there's anything that when we add it, will eliminate one of the variables immediately. All right. And if that doesn't work, we have to look at subtract. Is there any way I could subtract one expression from another and have that work? So here's what we're going to do then. Looking at these two equations, think about it like this. If we were to add the x with the x, so imagine like, you know, we're going all the way back to like elementary school or something, and you're adding something vertically. We're doing this similarly. Meaning, right, if I were to add these two expressions together, x plus x is 2x. Now look here, negative y plus y. What do you think negative y plus y is going to be? Yeah, nothing, right? So just as negative 3 plus 3 is equal to 0, negative y plus positive y is 0. So they cancel out. So it's a very interesting way of solving systems of equation question. So negative 6 plus 8, yeah, 2, right? Here we got 2x plus 2, divide both sides by 2, and x is 1. Look at that, right? Isn't that miraculous? So here we got x plus 1, and so what we're going to do now is, as usual, we're going to solve for y. So I'm going to use this one because, you know, that's easy, right? So I'm going to use this one as an example, and then I'm going to substitute and evaluate. 1 plus y equals 8. So what's y? That's right, 7. So the solution is 1 comma 7. Right? Super fast, actually. Because think about this. If we were having this conversation 2 weeks ago, you would be, I mean, think about this. If we were having this conversation 2 weeks ago, for the first equation, in order to graph it, you would have to subtract x on both sides, right? And you have negative x minus 6, and then you divide both sides by negative 1, and you have x plus 6, and then you have to do the same thing for this one, right? And then you have to put it, and then you would have to put it in the table of values, right? And then you have to graph it, whatnot, all that stuff, right? And that's just 2 weeks ago, right? If you were talking about what we did last week using substitution, then you would have had to solve for one of these, right? So it would have been y equals to x plus 6. And you have to substitute it into this equation. Not bad. Not a tough way to solve this, but I think you can see why this might take a little bit more time. So one of the things, the greatest challenge in you, once you've had learned this third way, is to figure out when is the appropriate time to use which method, right? And I would say, just to begin with, that in general, if you see two equations in the standard form, I'm going to write over my own work. If you see two equations in the standard form, go with elimination. All right, that should be the first thing that would come to your mind. All right, and that's all I got to say about that. All right, so having said that, why don't we try another one? Now here is a slightly different scenario, because remember what I said, right? You could either add or subtract. So here we just combine by adding, and fortunately, negative y plus y gave us 0, right? It canceled out, and therefore it left us with only x. So that was fantastic. It doesn't always happen like that, of course. So here now we have a second situation with the two equations. Now, here's the problem. Let's try to add it, okay? Just for an experiment's sake. So 2x plus negative 3x is negative x. Y plus y is 2y equals to 4. So you see how this didn't help you at all? Because you still haven't isolated one of the variables. You could isolate for either the x only or the y only, and somehow it did neither. So adding is not going to help you. So that begs the question, what should we do instead? And in this case, we would subtract. But subtract's tricky, right? Remember, like you have to, like, you're technically you're almost writing it like this, almost. You're kind of writing it like this. Now, no one ever writes expressions with an equal sign in the middle, but that's kind of what we're doing. All right. So I'm kind of saying it not very seriously, but you remember, if we were to subtract, we would have to distribute this negative sign, which is really a negative 1. Right? So let me use my magic marker. Right? This is really a negative 1, and distribute this to the different terms. So having said that, okay, the 1 still have it up. There we go. Right? So meaning, when we subtract, we have to be very careful, and you can see why I'm taking the time to put a parentheses around this second equation. So if you want to, you can rewrite it. All right. So, and then once you get good at this, you won't have to do it anymore. So we have negative times negative, that's positive, so that's plus 3x. Negative times a positive, so that's minus y. And then negative times negative 1 times 2. Now I can just combine them. I could add them. So 2x plus 3x is 5x. These cancels out, which is the whole point of doing this in the first place. So here I'm left with 10. Divide both sides by 5. And x equals 2. And now I'm going to substitute with this, the first one. So 2 times 2 plus y equals 12. Plus 4 plus y equals 12. So y is 8. So the solution is 2, 8. And if you don't believe me, you can substitute both of these in. So you substitute 2 here and 8 here. Right? 2 times 2 is 4, plus 8 is 12. You can try for this one too. So negative 3 times 2 plus 8 is equal to 12. Wait on. Negative 3 times 2 plus 8. Oh, I caught myself. All right, it's 2, it's not 12. All right, yeah, right. Negative 6 plus 8, is that 2? Yep, you bet. All right, so there's our answer. That's that. Okay, so why don't you try this one right now? Oh, I want to show you one more. Okay, all right, that's fine. We can try one more. All right, so let's see. You know what? Actually, I want to keep these videos short. So we're at 10. Yeah. You know what? Try this one yourself, right? And press pause. And then when I come back, I'll go over it with you. And then after this, we'll go back to class. Okay. So try this right now. So press pause right now. Okay. Hopefully you can see that the best way to go about it. Again, right, you have two choices. You're going to add the two expressions or you're going to subtract the two expressions. Hopefully you see that the best way to go about this is to add the two expressions. Because why? Because look at the 2x and 2x, right? Negative 2x plus 2x, that cancels out. That's good. So I got nothing here. I got 8y equals to 24. Divide both sides by 8. Equals 3, and so y is 3. Let me substitute that into the second expression. So 2 times x plus 5 times 3 equals 25. 2x plus 15 equals 25. Subtract 15. 2x equals 10. I'm working really fast because x equals 5. So our solution is 5, 3. And if you want to check your answers, you can substitute the solution into both equations, and you will see that your answer will be correct. Okay? All right. So let's see. You know what? Do we have time? Yeah, you know what? Let's go for it. Let's try one more. Okay? So right now, I would like you to try this. So press pause. Right. Now, with this one, notice, right? Again, the strategy is to identify a term. Actually, it's not true. It's actually identify two terms where if you either add or subtract, you can eliminate that term entirely, right? That variable in that term entirely. So look at this, right? 4x, 5x, nothing going on there. We can't add or subtract. Now look at the 2y and the 2y, right? Now they're both positive, so that's, you don't want that. So what do? You subtract. Now I'm going to do it the fast way. So whereas this one, I rewrote it, I'm not going to rewrite it because you don't have to, and you can work just as fast. Okay, you just got to remember you're subtracting. Okay, so 4x minus 5x is negative x. 2y minus 2y is 0. That cancels out. Good, that's exactly the point. 14 minus 16 is negative 2. Divide both sides by negative 1. X is 2. Substitute, I'll substitute in the first one. 4 times 2 plus 2y equals 14. That's 8 plus 2y equals 14. Subtract 8. 2y equals to 6. So y is 3. So the answer is 2 comma 3, and that's all there is to it. All right, so come back to class. We'll practice, and that's it. Okay, all right, come back to class right now.
OMG, that was so good.